All right, I gave a worksheet on doing inverse functions here, and I'm going to try to go through it here, especially for those that are not in class. Now, I had to raise my camera so high that it's going to be hard to see because it'll be kind of small. So, we're supposed to find f of a. A is 2, so we got to put 2 in here. So, 2 cubed is 8. So, we get put in 2 and we get 8. Now, f prime, the derivative of x to the third is, so dy dx, or f prime, is 3x squared. If I put 2 in there, I get 2 times 2 is 4 times 3 is 12. Now, if I find the inverse, oh, by the way, let's start right there, understand this up front. If I have a function, like this looks like x cubed, move up 1, 2, 3, 4, whatever it is, if we figure out the slope at a, b, and this is the inverse, if this was x cubed somehow, this is the cube root of x, but moved over 4 this way instead of that way, it's a reflection over the y equal x line. If it's the inverse, if a and b are in the original one, ba, notice they're switched around, the inverse takes it back. This function took a and made it into a b. This one takes b and takes it back to an a. So that makes it the inverse of that one. So its slope here, just looking at this, you can see that if this was like 1, let's see, goes up 3 for 1. So if this slope is 3 for 1, this one has a slope of 1 for 3. So the slope of the inverse looks like it's the reciprocal, the flipped over, upside down fraction, reciprocal of the slope of the function. So if g of x is the inverse of f of x, then g prime of x, its slope is 1 over f prime of x. The reciprocal of the f is the slope of the reciprocal. The reciprocal of the slope is the slope of the original. So what I'm trying to show you here is we're going to find the inverse function, and then we're going to check and make sure that the slope comes out to be the reciprocal of this. So the reciprocal of 12 is 1/12. So we should come up with 1/12. That didn't look like 1/12. 1/12 over here. Okay, to do the inverse, you swap the y and x. We did this in pre-calc 1. So x equals y to the third. And that's all we need to do there. And these two, we're not going to make triangles. The rest of these we will. And then solve for the y in column 3. So this is column 1, 2, 3, 4, 5, 6, so on. So solve for y in this. So to solve for y, I'd have to take the cube root. So y would equal the cube root of x. And we already know how to take the derivative of those by the power rule. But we're going to do the derivative of this one. Now, so using our chain rule, this is not a function of x. So the derivative of x is 1. The derivative of something to the third is the derivative of the inside, so it would be dy dx, derivative of the inside, or y prime if you will, times the derivative of the bigger picture, which would be 3y squared. So if I solve for dy dx, I'd have to divide both sides by 3y squared. here, and here. And so I get dy dx is 1 over 3y squared. But I would like to have it in terms of x's, so I'm going to replace the y with what y is equal to. And so I'm going to get I'm going to get dy dx is equal to 1 over 3 times y, which is the cube root of x squared. So, which is also 1 over 3 x to the 2/3. Which is what we would have gotten if we'd taken the derivative of the original one. This one here, that's x to the 1/3, so its derivative would be 1/3 x to the negative 2/3, which puts x to the 2/3 in the denominator. And this should come out to be 1/12. Now remember, we were doing this at the point 2, 8. The slope at 2 was 12. When we look at the inverse, we want to do the slope at the opposite. Not the A, but at the B. And the B is 8, so I got to put 8 in here for the x to get the 1/12. So I'd have 1 over 3 times the cube root of 8 squared. Well, the cube root of 8 is 2, squared is 4, times 3 is 12. And so there I get my 1/12. That's the idea on how you're going to do this one. But this is going to help us find out the derivative of the natural log. If I put 1 into e to the 1, e to the x, I get e. So putting in 1, I get e. So over here, I'm going to put in e and hope I get the slope that I would have from this. Now, the derivative of e to the x is e to the x. It's the only function that its derivative is itself. So if I put 1 in here, I get a slope of e. E to the 1 is e. So over here, I should get 1 over e. Now, swap the y and x in this, and I get x equals e to the y. To solve for y, I take the ln of both sides, and I get ln x equals y. So what I'm trying to find, since ln x is the inverse of e to the x, I'm trying to figure out what the derivative of ln of x is. So I'm going to go back to here and take the derivative. Derivative of the x is 1. Derivative of e to the y is the derivative of the inside. Derivative of the y is dy dx times the derivative of e to the y, which would be e to the y. Now, if this was an x, it would have been just e to the x. Didn't need that. But since it's e to the y, we have to do the derivative of the y times e to the y. Solving for dy dx, we divide by e to the y. And then replacing the y with ln x, we get dy dx equals 1 over e to the ln x. Well, e and ln are inverse functions. One undoes the other. So they undo each other, and we end up with 1 over x. So the derivative of ln x is 1 over x. And if the slope of e to the x was e at 1, the slope of ln x at e should be 1 over e. 1 over x, and the inverse, the x becomes the e, and the y becomes the 1 on the inverse. Okay, now let's do it for the sine. So we're going to try to find the derivative of arcsine, or sine inverse, the inverse function. Now if I put pi over 6 in here, the y value is, sine of pi over 6 is 1/2. So dy dx, derivative of sine, is the cosine x. And so if I put pi over 6 into here, I get the square root of 3 over 2. That's the slope of the cosine. So the slope of the inverse should be 2 over the square root of 3. That's what we hope to get. Now I'm going to work through it and see if I can get that, and actually find the derivative of arcsine, derivative of this. So if I swap the y and x, I get x equals sine y. And this is where things are a little different. We're going to draw a right triangle. And it says the sine of some angle is x. So I'm going to make that the angle. I like to draw my triangle every time with the y there. And this is x to 1, and the sine is opposite to hypotenuse, opposite over hypotenuse in the SOHCAHTOA. And if I use Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, and I solve for this side, I get the square root of 1 minus x squared. Use the Pythagorean theorem with, say, a here. A squared plus b squared equals c squared, and work it out, and you'll figure out that the a had to be square root of 1 minus x squared. We're going to use this triangle down the road here. Now it says solve for y in this one. So I have to get the sine off of there. That's where the inverse comes. So that means arc sine of x equals y. I take the arc sine of both sides, and that gets rid of the sine and leaves me arc sine of x equals y. Arc sine is also sine inverse of x. So we're finding the derivative of sine inverse, or arc sine. So it says now take the derivative of column 3. So the derivative of x is 1 equals the derivative of sine, well, we got of y. If it was of x, it would just be cosine x. But since it's of y, we have to do dy dx, or y prime, times the derivative of sine of something is the cosine of the something. If we solve for dy dx by dividing both sides by cosine y, we get 1 over cosine of y equals dy dx. But we want this to be in terms of x, so I go to my triangle. What is the cosine of y? There's y. Cosine is adjacent over hypotenuse, so dy dx becomes adjacent. First of all, I have 1 over, the cosine is adjacent, square root of 1 minus x squared over 1. This one doesn't matter, so that's the cosine. We get 1 over that. That is the derivative of arc sine. Derivative of arc sine is 1 over the square root of 1 minus x squared. If I put in the y portion of my original point, the half, I should get 2 over the square root of 3. So I got 1 over square root of 1 minus 1/2 squared. 1/2 squared is 1/4. 1/4 taken away from 1 is 3/4. So I have 1 over the square root of 3/4. So I get the square root of 3, and the square root of 4 is 2 in the denominator, which I can multiply numerator and denominator by the 2, and I end up with this. All right, let's figure out the derivative of arc cosine. So if I put pi over 6 into this, cosine of pi over 6 is square root of 3 over 2. So I'm going to put square root of 3 over 2 into the derivative and hopefully get the reciprocal of the slope of this one. Derivative of cosine tells me the slope, and it's negative sine of x. And if I put pi over 6 into that, I get negative 1/2. So over here I should be getting negative 2 over 1. All right, swap the y and x. So I got x equals cosine y. Draw a triangle where the angle is y, right triangle, and x over 1 is the cosine. X over 1, adjacent over hypotenuse. Using Pythagorean theorem, this becomes the square root of 1 minus x squared. And solving for y in this, take the arc cosine of both sides, and so I get arc cosine of x equals y, or cosine inverse of x equals y. Now take the derivative of this one, back in column 3. Derivative of x is 1. Derivative of the inside is dy dx times the bigger picture, cosine of y's derivative is negative sine y. Solve for dy dx by dividing by that, and I get 1 over negative sine y is dy dx. And so dy dx is 1 over negative of the sine, that's this opposite, over hypotenuse, the sine of y. And so that's going to be the square root of 1 minus x squared over 1, which is not going to change anything. So that's the derivative of the arc sine, or arc cosine. And if I put in the y, the square root of 3 over 2, I'm going to get 1 over minus the square root of 1 minus square root of 3 over 2 squared. Square root of 3 over 2 squared is 3/4. From 1 is 1/4. The square root of 1/4 is 1/2, so I get 1 over minus 1/2. Minus 1/2 goes into 1, minus 2 times. Okay, now we'll do the tangent. So at pi over 6, the tangent, which is sine over cosine, it's 1/2 over the square root of 3 over 2, which is 1 over the square root of 3. At pi over 6, the tangent is 1 over the square root of 3. So I'm going to find the slope of the arctangent at 1 over the square root of 3. Now the slope of the tangent is dy dx is secant squared x. That's the derivative of tangent. So if I put pi over 6 in here, secant squared is 1 over the cosine. Well, the cosine of pi over 6 was square root of 3 over 2. So 1 over it would be 2 over the square root of 3. And if I square that, I get 4 over 3. That turned upside down and squared. Okay, now let's find the inverse of this, which is x equals tangent y, swapping the x and y, making a triangle that looks like this. Now I got to be careful. This is x to 1, but tangent is opposite over adjacent. So if y is there, that's the opposite, that's adjacent. And to find the hypotenuse, it's a squared plus b squared equals c squared, so it's square root of 1 plus x squared, or x squared plus 1. Solving for the y, it's going to be, I got to take the arctangent of both sides, so arctangent x equals y, or tangent inverse of x equals y. Taking the derivative of this one, derivative of x is 1. The variable this is a y, which is not x, so we have to go dy dx times the derivative of tangent, which is secant squared with the same thing inside, secant squared y. Solving for dy dx, I get 1 over secant squared y is dy dx. Don't want y, so I'm going to solve for secant of y. Well, 1 over secant squared, 1 over secant is cosine, so this is just cosine squared of y. So I'm going to do dy dx is going to be 1 over the cosine. The cosine is 1 over that. Cosine squared is going to come out to be 1 over 1 plus x squared. I'm supposed to be able to put 1 over the square root of 3 into this and get the reciprocal of 4/3, 3/4. So if I put in 1 over the square root of 3, I got 1 over 1 plus 1 over the square root of 3 squared. 1 over square root of 3 squared is 1/3, plus 1 is 4/3, which is 3/4, or the reciprocal of 4/3. All right, cosecant. Cosecant is 1 over the sine, so if I put pi over 6 in, well, what do I get? The sine of pi over 6 is 1/2, so the cosecant is 2 over 1, or 2. If I find the slope of the cosecant, the dy dx, derivative of cosecant is negative cosecant x cotangent x. The inverse, or the swapping the y and x in this, we get x equals cosecant y. So I got to make a triangle where the angle is y, right triangle, and the cosecant, which is 1 over the sine, is x over 1. Well, the sine is opposite over hypotenuse, so the cosecant is the hypotenuse over the opposite. So x is on the hypotenuse and 1 is on the opposite. And if I do that, this becomes the square root of the hypotenuse squared minus 1 squared. Do a squared plus b squared equals c squared with x and 1 here and a there, and solve for it, a, and you'll get this, hopefully. Now, if we're solving for the y in this, we got to take the arc cosecant of both sides. So we get arc cosecant of x equals y. And this is our goal, to find the derivative of this, or cosecant inverse x equals y. What is the derivative of that? So taking the derivative of this will help us get there. Derivative of x is 1. Derivative of the inside is dy dx times the derivative of cosecant, which is cosecant y cotangent y. And so solving for dy dx, we get 1 over cosecant y cotangent y equals dy dx. And so therefore dy dx, using the triangle and looking at the cosecant is, so we got 1 over cosecant. Cosecant was 1 over the x, so we get x. And it turns out this needs to be absolute value. I'm not going to try to explain that one now. And then the cotangent. Well, the tangent's opposite over adjacent, so the cotangent's adjacent over opposite, so it's the square root of x squared minus 1 over 1. So there is the derivative of cosecant. Let's see here. Oh, I forgot something, did I? Oh, yes, the derivative of cosecant is negative of this. There should have been a negative there. So this has got a negative on this part, so it's negative. So now let's see. Oh, we never did the slope at pi over 6. Cosecant of pi over 6 is the reciprocal of sine, so it's 2, negative 2 times cotangent is cosine over sine. It's tangent is sine over cosine, so cotangent is cosine over sine. The halves cancel out, it's the square root of 3. So here we're hoping to get 1 over a negative 2 square root of 3, the reciprocal of this. So we're going to put in, now we put in 2 for that. So we get minus 1 over absolute value of 2 square root of 2 squared, which is 4 minus 1, 3. Matches. Got 2 more, and I'm running out of time. I need to be someplace here soon, so let's see if I can get this done. All right. Pi over 6. Secant is reciprocal of cosine. So if I put pi over 6, cosine of pi over 6 was square root of 3 over 2, so this is 2 over the square root of 3. Dy dx, the derivative of secant is secant x tangent x. So if I put pi over 6 in for the secant, I get 2 over the square root of 3 times the tangent of pi over 6, which we did up here, 1 over the square root of 3, and we get 2 over 3. So the inverse, the derivative of secant E inverse, or arc cosecant, should be not 2 over 3, but 3 over 2. Now let's see if we can get there. Swapping the y and x, I get x equals secant y, making a triangle where the secant is okay. Something seems wrong to me here. Let's see. Thinking secant is the reciprocal of cosine, so it's 2 over the square root of 3 times tangent, which is 1 over the square root of 3, so it's 2/3. Okay. Secant of pi over 6 is 1 over cosine. All right, let's see if this works out. I hope I didn't make a mistake here. Okay, x over 1 is the secant. Secant's 1 over the cosine, so the cosine is adjacent over hypotenuse if this is y. So the secant is a hypotenuse over adjacent, so it's x over 1. Solving for this side, I would go hypotenuse squared minus leg squared to get that. Solving for y in this, arc secant y, x equals y, or secant inverse of x equals y. Taking the derivative of this, derivative of x is 1 equals, you see how this derivative of x is showing up every time as 1, equals dy dx, the derivative of the inside, times the derivative of secant, which is secant y tangent y. Dividing by the secant y tangent y, we get 1 over secant y tangent y is dy dx, and so we have dy dx, getting rid of the secant. Secant was x over 1, so we got 1 over x, that's the secant on this triangle. It also should have absolute value, times the tangent of y, which is this opposite over adjacent. So it's the square root of x squared minus 1. And if I plug in the y value, 2 over the square root of 3, hopefully I get this. So I get 1 over 2 over the square root of 3 in absolute value times the square root of the x squared, which is 2 over the square root of 3, square root of 2 over the square root of 3 squared minus 1. So that's 4. Oop, got something wrong here. 2 over the square root of 3. So that's 4 thirds. 4 thirds minus 1 is 1/3, so maybe not. So this is the square root of 1/3. So we got 1 over 2 over the square root of 3 times square root of 1/3, which is 1 over the square root of 3, which is 1 over 2 over 3. 2 over 3's reciprocal is 3 over 2. I'm right. That's scary. Okay, and finally, the cotangent. So if I put in pi over 6, cotangent's the reciprocal of the tangent, so it's square root of 3. Derivative of cotangent, is negative cosecant squared x. So if I put pi over 6 into the cosecant, I get 2. I square 2, I get 4, so I get negative 4 is the slope. So hopefully down here I get negative 1/4. Solve for, swap the y and x, I get x equals cotangent y, making a picture of that. Cotangent's adjacent over opposite as opposed to tangent was opposite over adjacent. Got to remember your trig. And I got x over 1, so it's x over 1. Using the Pythagorean theorem, I get the square root of x squared plus 1. To get rid of the cotangent on here, I do arc cotangent. X equals y, or cotangent inverse of x equals y, either one of those. We're trying to find the derivative of that. We're going to take and do the derivative of x, which is 1, derivative of the inside, times the derivative of cotangent. And so now we solve for dy dx, and that becomes 1 over minus cosecant squared y is dy dx, but 1 over cosecant is sine, so this is just minus sine squared y. So dy dx, the sine of y is 1 over this. We have a minus, and sine of y is 1 over the square root of x squared plus 1, and we have to do the sine squared. So the derivative of arc cotangent or cotangent inverse is minus 1 over the square x squared plus 1. The squaring gets rid of the square root. So if I put in my y, square root of 3, square it, I get 3 plus 1 is 4. I get 3 plus 1, 1/4.